So you already know what a rational number is. It's a number that can be expressed as A over B. It's a ratio number. We also have rational functions. Now, a rational function is a ratio between two functions. So f of x over g of x. Now, the functions are specific. They have to be polynomial functions. So they could be linear, they could be quadratic, they could be cubic, they could be quartic, but they have to be polynomials. So some examples of rational functions. That's a rational function because it's a linear function over a linear function. That's a rational function because it's a quadratic over a linear function. And that's a rational function because it's a quadratic over a cubic. But we're going to focus on simpler ones, linear over linear functions. Specifically, I want to be able to sketch functions that look like that. So let's get started. So we're going to sketch this rational function here, 2x plus 5 over x minus 1. Now, I want to cheat and I want to do it using GeoGebra first, so we know where we're going to get to. Okay, so I've sketched it, and I've got to say it's a little bit surprising and a little bit familiar looking. So there's our y-axis, there's our x-axis, and we've got this hyperbola thing going on. A hyperbola with asymptotes around about there, and around about, I don't know exactly, but like somewhere down there somewhere. So how have we ended up with a hyperbola with asymptotes like this? I don't know. But what I do know is that hyperbolas have a specific kind of general form. Something like that. A number over x minus h plus k. And the h and the k values tell us what our asymptotes are going to be. So the fact that this function looks like a hyperbola tells me that we should be able to express it like this as a hyperbola, or at least that's my theory. So let's think about what this actually says. 2x plus 5 divided by x minus 1. We're dividing one function by another. Polynomial division. So 2x plus 5 divided by x minus 1. Okay. 2x divided by x is 2, and that gives me 2x, and then 2 times negative 1 is negative 2. Subtract 1 from the other, 5 minus 2 is 7. Okay, what does that mean? What does it mean when we do polynomial division? Well, it means that if I do 2x plus 5 divided by x minus 1, the answer to 2x plus 5 divided by x minus 1 is 2, with a remainder of 7. What does a remainder of 7 mean? A remainder of 7 means I wanted to divide 7 by x minus 1, but I couldn't. I still have to do it. I haven't been able to do it yet. I really wish that I could do 7 divided by x minus 1, but I couldn't get an answer to that. And we can represent that as leaving it exactly like that. 7 divided by x minus 1. I tried to divide 7 by x minus 1. I couldn't, so I leave it. 7 divided by x minus 1. If I rewrite that, just reversing things, 7 over x minus 1 plus 2, that's a hyperbola. That's a hyperbola. So let's see if that matches with the picture that we had. Okay, so the 2 tells us the asymptote here, and that matches up. That's the number 2 right there. And the minus 1 tells us where our asymptote is. But remember, you have to reverse that. So the asymptote's not negative 1, the asymptote's positive 1. Alright, so now that we know that our function, 2x plus 5 over x minus 1, is actually 7 divided by x minus 1 plus 2, we can sketch it the way that we've sketched hyperbolas before in maths methods. Alright, so the hard bit really was doing this polynomial division and expressing our rational function, not like this, but expressing it like that instead. And then we just sketch it. That's it.